I think the most important is that we successfully delivered a solution connected to the supercapacitor industry in Europe, starting from the material, going all the way in order to deliver the demonstrators for two use cases, one for the smart clothing and also for the electromobility. On the programmatic side, as a coordinator, it is also very important for us. All these 3 years, everything went well. We delivered everything on time. And for me, personally also, is that after these 3 years, I have some great friends spread around all over Europe. Well, we're talking about supercapacitors, which of course is an energy storage component. The supercapacitors, for me, is a complementary power component. It means that it's a component that mainly focused for applications that they have large power fluctuations. Everything that you do for this industry, it promotes, let's say, Europe that is more independent and more sustainable. More and more applications demand a lot of power in our daily life, starting from renewable energy sources, going to consumer goods and electronics, etc. The most you develop inside Europe these technologies, the more beneficial would be for everybody, for the society, for the industry, for the market, because it's a very large discussion this year. Everything that promotes the industry of energy in Europe and makes it more independent, so at the end more sustainable in high level and more viable at the end.
Within the Emphasis project, we developed many new electrolytes. This includes ionic liquids and salts, and we were able to do this with really effective collaboration between the partners, but specifically between Solvionic and the University of Würzburg. One of the things we did was we looked at 2 different electrolyte classes, and we were able to demonstrate both amide and cyanoborate anions, or ionic liquids based on both of these anions in both lab scale and larger prototype cells. In addition, we looked at polymer electrolytes. This is particularly interesting for things like safety, and we were able to see that the performance was just as good as a liquid electrolyte with a separator. We specifically addressed the challenge of low temperature performance for ionic liquids. This is something that's often challenging simply due to crystallization effects and viscosity of ionic liquid, but we were able to have cells that functioned at -50 degrees through the use of ionic liquid electrolytes. One of the challenges in terms of the commercial application of ionic liquids is always scalability. Solvionic has been able to demonstrate a continuous synthesis and purification process up to a scale of over 1.5 tons per month. And this has enabled them to reduce the cost of amide-based ionic liquids by almost 50%. Within the Emphasis project, we have been able to demonstrate electrolytes with improved sustainability along the full supercapacitor value chain. Our results demonstrate the importance and the potential in alternative electrolytes, not only for supercapacitor applications, but also for energy storage in general. For example, the electrolyte components that we've developed within this project can be used, for example, as additives for lithium-ion batteries or sodium-ion batteries, or to form the basis of related compounds for these sorts of applications. In an industrial context, upscaling is a really important step. Cost has long been considered one of the significant disadvantages of ionic liquid electrolytes, and through the continuous process that has been developed and demonstrated by Solvionic, they've shown up to a 50% reduction of cost for their amide-based ionic liquids. The work that we've done here is really showing the potential of alternative electrolytes and specifically ionic liquid-based electrolytes in the field of energy storage.
Well, the first constatation is that many scientific and technical objectives have been reached. For instance, in the field of flexible supercaps, the use for technical textiles and clothes. Pilot lines have been also developed, allowing the optimization of products and processes in the fields of graphene synthesis and ionic liquids production. The multidisciplinary approach generated new ideas and brought solutions that are now mature enough to envisage effective technology transfer and access to an industrial and commercial activity. But further steps are still necessary, of course, gathering existing and new stakeholders. It therefore opens the door to new milestones to achieve regarding the collaboration beyond the project. Necessary synergies have been deeply discussed today with the help of sister project partners and external stakeholders. And we have identified several pathways to the potential markets. The Emphasis project allowed testing two use cases: textile application and automotive application. And for the latter, the results were found surprisingly very promising. The consortium partners are already involved in a global roadmap for improving the energy challenges in Europe. Several projects, including new generation of supercapacitors, have been launched with the support of the European Commission. New perspectives will involve, among others, licensing pathways in order to enable the exploitation of the results. The industrial partners of Emphasis are already dedicated in these projects, hence validating the wider impact strategy set out by the project. The focus is now on the access to the market, considering the technologies and materials that have been developed thanks to the Emphasis project.